Hey guys, welcome to another session on math for data sciences. So here we would be going through the variable level of measurement for variables which we looked at in the previous session, and we'll be looking at something how we can handle categorical variables in machine learning models. So first, what we saw in our previous session was we saw the four levels of measurements and of variables, and these were called nominal, ordinal, interval, and ratio level variables. Also, we saw that as we go from left to right, there was some new feature which was added at each level of measurement. So for example, for nominal variable, it is a simple categorical variable where there is no ordering possible in the possible values for that particular variable. A simple example which could be a color. So if we have colors like blue, green, and red, we cannot really place them in a particular order. We cannot say that blue is greater than green and so on, and therefore these are nominal level variables. Then going from nominal to ordinal, we have an order to the values of that variable which are added. So that is the extra feature added to the ordinal variables. And an example of that could be, let's say, a rating for a movie. So now the rating could be either 1 star, 2 star, 3 star, 4 star, or 5 star. Now, one thing to note here is both nominal and ordinal variables are qualitative variables, which is also called categorical variable. So this is still categorical variable. Now, one can say that the values here are numerical. So why are we categorizing it as a categorical variable? The reason being, even though the values are numerical here, the meaning of those values are not really numerical, because we cannot really subtract these values from one another, and therefore they don't follow the arithmetic properties like a numerical variable would. So there are no arithmetic properties possible here, or no arithmetic operations allowed. So we cannot really say that a movie which is rated 4 star and a movie which is rated 3 star, the difference between them is same as the difference between the movie rated 2 star and movie rated 3 star. Even though the difference is 1, but we cannot really say that the rating itself has that particular difference. So the meaning itself does not come out with the in the form of differences for ordinal level variables. Next, we move on to interval level variables. So the extra feature which is added here is that the differences are now meaningful for interval level variables, but there is no true zero to this kind of a level of measurement. So an example for this which we saw in our previous session was temperature, where we know that temperature can be negative as well, and therefore there is no stoppage to the number line at positive values. So if we have 20 here, we can have minus 20 here, and therefore although we can subtract 20 from 0 to get 20 and 0 from minus 20 to get 20, so the differences have a meaning here, but we don't have a true zero here. And this was also the reason that we cannot really calculate the ratios for interval level variables. So for example, if the temperature value is, let's say, 20 and another temperature value is 10, so let's call it temp 1, temp 2, we cannot really say that the temp 1 value is twice hotter than temp 2 value. In terms of numerical, although it is twice, but in terms of variable meaning, we cannot say that the first temperature is twice as hot as the temperature 10, because there are negative values also possible, and therefore we cannot calculate the ratios in this particular case. Finally, we looked at the ratio level variables, and as expected, the extra feature added here is there is a true zero. And a very simple example of this could be, let us say, salary. So employee salary. So this could, since the employee salary cannot be negative, therefore there's a true zero to this level of measurement. And we can also calculate ratios. So if we say that there is a salary value, let us say $1,000, and then there's a salary value of $2,000, we can easily say that S2 upon S1 is 2, which means the salary of the second employee here is double the salary of the first employee. So once again, the interval and ratio level variables are quantitative variables or numerical variables, while nominal and ordinal variables are qualitative or categorical level variables. So this is regarding the level of measurement of the different kinds of variables which we'll encounter whenever we are doing a data sciences project. So next we move on to something called variable encoding. So this is like one of the first applications in whatever we are studying here. So this is one of the first application in pure data sciences. So this will be directly used in our future projects, which we'll be looking at whenever we are looking at any machine learning project. So what variable encoding means is machine learning machine learning algorithm cannot directly interpret the categorical level variables. So it cannot really interpret characters like blue, green or red. So basically for categorical level variables, we need to change them somehow to some numerical form which the algorithm could understand. So all the algorithms which will be looking in future, they would want some numerical input and not categorical one to run the algorithm or to use that particular feature in their algorithm. So now there are different ways that we can handle this particular situation where we want to convert the categorical variable into their numerical equivalent. So how we do that? So first we'll be looking at, let us say, nominal level variables. Now for nominal level variables, just like we have the variable color here, there could be a couple of ways that we can convert them into numerical form. One could be that let us say we have blue, we assign this value 0, then we have green, we assign this value 1, and then there is red and we assign this value 2. So now we have a numerical form here, and therefore the machine learning algorithm would be able to understand, and this kind of encoding is actually called label encoding. Now, since we are converting them into these values randomly 0, 1 and 2, we have to note that this has one disadvantage here, because 0 is less than 1 and 1 is less than 2. Now, there could be many more colors and therefore we can have categories 3, 4 and so on. So now what we are actually doing is we are converting the nominal level variable into some kind of an ordinal level variables, because we are giving these values a particular order, which algorithm might think that green is actually greater than blue and red is actually greater than both green and blue. So this is one of the disadvantages of label encoding, that we are giving it a particular order for different values, which should not be the case, because nominal level variables do not have values which can be in a particular order. So to encounter this, what we use, so this was the first kind, label encoding. Now the second kind of encoding for nominal variables, which makes more sense, is called one-hot encoding. Now what this does is, let us say we have three colors, blue, green and red. So what it does is it creates multiple columns for each value of the variable. Now let us say we have a column color, and let us say we have various observations. So let us say we have three observations here. The value of color variable for first observation is blue, for second observation is green, and for third observation is red. Now it creates a new variable. Let us say we call it B, variable B, and the variable B is equal to 1 only when the color is blue. So in this case it will be 1 here and 0 and 0. So it is 1 when the color is blue, otherwise it's 0. Similarly, we create another variable and let us say we call it G, and this is equal to 1 only when the color is green, otherwise it is 0. So this is 0, 1 and this is 0. Finally, we have a variable red, R, which is basically 1 when the color is red, obviously. So this becomes 0, 0, 1. So now what we are actually doing is if there are n possible colors, we are actually creating n possible new variables in the data, and we'll be finally using these three columns as the input features for our algorithm instead of using the original color column. Now, in one hot encoding, these three new features which are generated, or you can say these three new variables which are generated, are called dummy variables. Now, one thing to note here is we had n categories here, and we created n dummy variables, because for each color we are creating a new feature. Now the problem with this is that we are actually putting one extra column here. The reason being, let us say we take these three columns together. So we know that blue is 100, so this is blue. Then we know that green is 010, this is green, and red is 001, this is red. But now let us say we only take the the first two columns, and we simply remove or omit this particular column, which was the red column basically, and in that case we would be left with 10 as blue, 01 as green, and 00 as red. So now one can easily see that even though we removed one of the column here, we are still getting three distinct combination of the remaining two variables, which can denote the three colors in a distinct manner. Therefore, one has to remember that for n categories of a particular categorical variable, we only need to have n minus 1 dummy variables. And this whole encoding process is called one-hot encoding. So this is the most used encoding process for nominal level variables. And one can see that we need n minus 1 dummy variables for n categories of a nominal variable. So this was regarding the nominal variable, and next we would be looking at our second categorical level of measurement, which was called ordinal data. So how do we do the encoding for ordinal data? So we'll be looking at one way only here in this case, and it is called ordinal encoding itself. Now let us say we have a variable which is basically measuring the experience, or you can say experience of a particular student in a particular school, and he can rate it as, let's say, very good, good, average, bad, or let's say very bad. So there are clearly 5 categories here, and one can imagine there's a clear order to these categories. So very good is better than good, good is better than average, average is better than bad, and finally we have very bad. So there's a good order to it, and therefore this is an ordinal level variable. So what happens in ordinal encoding is we simply assign values in the same order. So we will have 1 for very bad, 2 for bad, 3 for average, 4 for good, and 5 for very good. So unlike the label encoding, which we were doing in nominal level variable, here we can see that in case of nominal variable, it didn't make sense because the different colors, we were actually giving them a particular order, which is not really allowed for nominal level variables, and that was a disadvantage of label encoding. But in case of ordinal data, ordinal encoding helps because we have a particular order to these different categories of that variable, and therefore ordinal encoding in case of ordinal data makes sense to use. So we saw a couple of encoding techniques in nominal level variables, which was label encoding and one-hot encoding, and we normally use one-hot encoding for nominal level variables, and for ordinal level variables we use ordinal encoding, which is nothing but just assigning these values 1 to 5 to each of the categories in the same order in which that particular variable is measured. So this is regarding the variable encoding, which is nothing but a technique used to basically convert the categorical variables into some kind of a numerical format so that they can be used by the machine learning models, which typically require a numerical input. So that's it for this particular session. So in the next session, we'll be moving to some of the very simple stuff in statistics. We'll be looking at the measures of central tendency and measures of variation. And we'll also be looking at one of the plot, which is normally used to analyze data initially whenever we get a new data set. Thank you.